Hi everybody, it's Mr. Bennett here. Now in today's video I'm going to be looking at indices laws. Now a couple of things that you need to know about this first up is what an index is, so let's do that. So if I did something like 2 times 2 times 2, then I could write that as 2 to the power of 3, and then obviously you could write that as an answer as well. So they generally will have an answer. So if I then consider something like this, 2 by 2 by 2, and then we're going to times that by 2 times 2 times 2 times 2, then how many 2's do we have there? Well, it's pretty simple. We've got 7 2's, so I could write that as 2 to the power of 7. The idea of using indices laws is so I don't have to do all that extra work. All right. So this bit here, I could times and write that as 2 to the power of 3 and 2 to the power of 4. And we know that's equal to 2 to the power of 7. So the rule here may be, when we're looking at timesing, is I could write this as 2 to the 3 plus 4. And that's equal to 2 to the power of 7. All right, so when we're doing things like timesing base numbers together, then what we are going to do is we're going to add the powers. All right, so there are some distinct rules here. Now, we generally use general terms. All right, so if we did something like x to the power of n times by x to the power of m, the first rule we're going to have is I'm going to write that as x to the power of n plus m. So that's our first rule. All right, we're going to do something similar to that when we're doing dividing. So if we did x to the m over divided by x to the n, then our thing is going to be x to the n take m. So we take the powers away. All right, third rule. All right, we've got x to the n, and we're going to times that whole thing to the power of m. Then that's going to be equal to x to the n times by nm. So we're timesing those powers together. Next one. This one relates to anything to the power of 0. Anything to the power of 0 is in fact equal to 1. All right, so that's actually quite a useful one to use. Rule number 5. If we have x to the n, and that's 1 over x to the n, when we bring something to the highest or up to the top line, we change the power, we put it to a minus power there. All right, so when you bring something up or bring something down, you change the power to whatever the opposite is. And generally, that's probably the one we do the most of there. All right, so come over to here, number 6. So when we start looking at indices in terms of a surd, all right, x to the square root is equal to x to the half. All right, if we did, and we continue that down, x to the cube, that's equal to x to the 1/3. All right, so if we want to make a general rule for that, then we're going to do something like this. X to the n of x is equal to x to the 1 over n. All right, and then we've got another example that would be if we have something like the x has got some power to it, then we could write this as simply n, the square root of x to the m. So then that would be equal to x to the m over n. All right, and that one there is a bit tricky for a lot of people. They don't remember that, and they often get into trouble with that one there. The surds is one that certainly plays around with people's heads. So simply the square root of x is x to the power of a half. The cube root of x is x to the power of root 1 over 3, and so on and so on. The main thing is these things can be written down in front of you. You've got to use them to simplify doing algebra when we have expressions. Really useful way of saving a lot of time is using these rules here, and you need to know how to use them.